Hi, welcome. Just to make sure you're in the right session, this is session ID BRKARC-2023. The session titles Building Hybrid Clouds and Amazon Web Services with the CSR 1000. My name's Chris Hocker. I'm a solutions architect with Cisco. And
Solutions architect with Red Hat Ansible.
So as a solutions architect, I work predominantly in the field with customers. And I particularly cover US federal government. So it's a pretty diverse set of customers. You have small agencies with 100 employees, large agencies with tens of thousands of employees. You have agencies that have thousands of sites. You have some that are predominantly, most of their users are internal users. So maybe they're a regulatory agency. So all their end users are primarily internal. And then you have others that are providing citizen services. So they have a lot of external users interfacing to the public. In the context of cloud, there are federal mandates that drive adoption of cloud, but there's a full spectrum of maturity levels. A lot of them are just getting started in cloud, and there are some that have been using cloud for several years that are in production at scale. The standard architecture that they have is they'll have an on-prem environment, and then they're adding public cloud to that. So they effectively have a hybrid IT strategy, what most enterprises have. And most of them are also intending to use multiple public clouds, what we call multi-cloud. So maybe one of them is predominantly in AWS today. They're also using Azure, planning to use Azure, maybe Google. And there's a variety of reasons for that. Cloud lock-in would be one. Some, they just might want to use particular services, or they're focused on particular technologies. They're available in certain clouds, so maybe you're Microsoft-centric and you want to use Azure. But one area they absolutely have struggled with almost every time is the cloud networking component. How many people in the room are network engineers? Okay. That's my experience, is most of the time it's a networking team that gets tasked to do the cloud networking. And there's a challenge with that for a lot of reasons. One is that the public cloud networking works nothing like on-prem for the most part. I mean, concepts are similar, but they work differently. And then in the multi-cloud scenario, different public clouds work different from one another. And there's a lot of connectivity options. And obviously, your cloud architecture is key to the success of the cloud deployment, because it's going to affect performance, it's going to affect scale, it's going to affect security. So you ideally want to get that right. So what I'll cover today, so just with that context, most of these are practical designs and design concepts and techniques that I've seen customers deploy. So everything I talk about in here, I know at least one or more customer that's deployed, these architectures or this concept. So now I would caveat that every customer is different in the cloud as they are on-prem. They all have their own priorities, their own requirements, their own technologies they're using. So none of them are the same. So I'm trying to generalize here so you can apply these concepts into your own environment. Please feel free to ask any questions that you have, either live. So I've budgeted time for live questions. And then we also have Fan Yang from the product team. He's in the room, so he'll be moderating the WebEx Teams room. So he's from the product team that supports the CSR 1000. So any questions you can ask either in the WebEx Teams room or live. And we'll be monitoring the WebEx team room over the next week. So if you have any questions beyond today, feel free to post them in there. This is the agenda that we'll be covering. So we'll start off with an overview of the CSR 1000, and then an overview of the AWS VPCs and how they relate to each other. How does a CSR run in a VPC? Then we'll do an architecture discussion. So what are some of the topologies that customers use? What are some of the connectivity options? And then what are the use cases for CSRs to augment those architectures? Then we'll cover advanced features and use cases. So the CSR is an enterprise class routing product. What are other capabilities on that platform that are relevant for public cloud deployments? So I'll cover some of those in the advanced features. I'm also at a high level going to cover CSR in Azure. So I would say when I was doing this a couple years ago, maybe 90% of the engagements were AWS. I would say today it's almost 50-50 AWS and Azure. So there's a lot of interest in Azure deployments of CSR as well. And that is one of the other use cases, is multi-cloud. I want a consistent product and architecture and capabilities and operational model in my different cloud environments. So I'll cover CSR and Azure at a high level, compare and contrast it to AWS. And then we'll talk about automation. So if I distill cloud down into one key thing, it's self-service driven by automation. So a developer or user wants to provision a service. They go to the AWS console, they provision that service, they get virtual machines, they get infrastructure. We need our network to be consumed the same way. So we need to be agile and automated in our network, just like we're automating the rest of the infrastructure. So we'll have a section on automation, and that's actually where Stephen is going to do a demo of just the concept. So we're going to use Ansible to automate deployment of a VPC, of CSRs into that, and show, not necessarily that implementation, but what that experience might look like, and so why that's important. And then we'll wrap it up with summary and next steps. So starting off with a basic overview. How many are using AWS today? Familiarity with it? How many are using CSRs? Okay. So some of this might be reviewed for you if you've got experience. CSR 1000 is a iOS XE routing platform, so it's closely related to the ISR 4000, the ASR 1000. Those are hardware appliances. The CSR is a virtual machine form factor, so it runs on hypervisors, but it's the same capabilities, it's managed the same way, configured the same way, has the same set of services. So it can run on on-prem hypervisors like ESXi, or it can run on Hyper-V, or it can run on OpenStack, KVM. It can run on NFV appliances as well. And in the context of this discussion, the public cloud hypervisors, AWS and then also Azure. And we have Google coming soon as well. I think, what's the time frame on Google? Next month. Okay, so we have Google coming soon. If you want to get access to the CSR in AWS, you do it through the AWS Marketplace. So if you connect to the AWS console, you go to the Marketplace, search on Cisco CSR, and you'll get some hits. You'll see the Cisco appliances in there as well. There's ASA and iOS XR, and there's a bunch of virtual appliances in there. So for the CSR, these are the key hits that you'll get. These are the three main options you have to choose from. Is my audio in and out? It sounds like that to me. Okay. So the first one is the BYOL license, or the BYOL model. They're different from each other just on licensing, so it's all the same products. The BYOL is, I'm going to launch a instance, so a virtual machine. I'll pay Amazon for the compute costs, and I'll acquire my license from Cisco and put that on the router. When you launch that, they launch in unlicensed mode, which is actually pretty cool because they're fully featured. They're just bandwidth limited to a megabit per second. So if you're testing and you're just trying to validate, how the CSR works, validate a topology, you don't need to do performance testing. The BYO instance you can use indefinitely for free. I mean, you have to pay the compute cost to Amazon, but it's a good way to get started. And then obviously, if you're a Cisco customer today, that's probably the easiest way to consume it. The other two are the Amazon billing model. So in this case, when you launch the instance, you're paying Amazon for not only the compute cost, but also the licensing cost. And then they reimburse Cisco on the back end. The difference between 2 and 3 are just the feature sets, the technology packages. These are the feature sets that are available on the CSR. So this is applicable, across the CSR, whether it's public cloud or not. So we have IP base, and it has a pretty standard set of most features that you would care about. On top of IP base, you can layer security, which would include VPNing and firewalling, or AppX, which is our advanced routing features. So things like MBAR2, MPLS, AVC are in AppX. For public cloud use cases, almost every time the use case is for terminating VPN tunnels. You'll be terminating some type of tunnel on it. So security is almost always the starting point for what you're using, the license you'll use in public cloud. Then the question is, do you need advanced routing features on top of that? And if you do, you use the AX license, which is a combination of everything, AppX and security and IP base. So as you saw on the previous page, it was security and AX, because you're always starting with security generally, and then if I need advanced routing features, I get the AX license. Yes, is there a question? Yeah, so the BYO instance, when you launch this, it runs with the AX license capped at a megabit per second. So And then if you want to do performance testing, you can go to the Cisco license portal and get a 60-day temporary license as well if you need to test performance once you validated your topology. So these are the performance numbers just for reference that we have today. So this is as of 16.8.1, and this is for 1,400 byte packets. And it also, if you compare the numbers to last year, it's slightly down. There was some performance impact with the Intel bugs. And that just isn't a CSR thing that affected all kind of x86 platform. But you can see at the C48XL, that's the biggest instance we support. We go up to 4.5 gig with crypto. So the IPsec for crypto versus non-crypto. And then we scale down to T2 medium, which is 220 megabits per second, and then scale it in between. So you pick what performance you think you might need, kind of match it up. And these are large packets, which are generally a safe assumption for cloud environments. But if you know you have smaller packets, you might need to budget in some extra performance. All right, so that was a brief overview of the CSR. If you're following along on the slides, I have a ton of hidden slides in this. I probably have more hidden slides than I've exposed just for timing purposes. So in everything I talk about, there are more background slides that fill in some of the details. So I'd encourage you to go there. But just a brief overview to set a baseline on the CSR. So next I'm going to talk about Amazon VPCs. So Amazon's a public, it's a shared environment, so VPCs are their way of taking up and carving out isolated networking environments. So you can think of it as like a tenant, or maybe like an MPLS VPN if you're used to MPLS technologies or that kind of segmentation. But in AWS, you generally will have more than one VPC. So I have customers that have hundreds of them. And how you use VPCs and consume VPCs is kind of, it's up to you. It's up to your operational model. Typical things are people have different VPCs for development, for production, for test, and QA. They have different VPCs for different programs or business units or projects or different development teams. So as you start to scale and you get more mature, you'll see an increase in the number of VPCs that you're going to consume. And that is one thing that we keep in mind in some of the architecture discussion is how to scale that out. So I create a VPC and I allocate a CIDR block to it. So this is generally not RFC 1918, but it could be whatever CIDR block you want. And then once I create the VPC, I start allocating subnets within that VPC. Subnets are created not in quite the same way as on-prem where we're trying to limit broadcast domains. It's more around routing and security policy. So I can assign different routing policies and obviously different security policies for the different subnets. So it's not quite the usage of them is a little bit different in AWS. And when we talk about availability zones, like subnets can't span availability zones. So that's another usage. If you're doing HA within your VPC, you need multiple subnets to do that. So once I've created the subnets, there's a concept that doesn't really exist of like a VPC router. So there's VPCs built in have ways of forwarding traffic within the subnet and between the subnet. And it looks like a router, but there's no really router there. You'll see .1 is reserved for all your subnets as your default gateway. But really, it's just an encapsulation. When you send something to the first subnet on the router, or in that subnet, it's a signal to AWS that you're trying to route between subnets. So when they find the instance you're sending it to, they change the encapsulation to make it look like a routed decision instead of a layer 2 decision. If it's within the subnet, they don't change the encapsulation so it looks like layer 2. This is the trend for on-prem technologies as well. If you are using EVPN, VXLAN with Anycast Gateway or ACI, they do similar types of things where everything, all the L2, L3 decisions are just local. There's no like router that you're going through per se. So I have a VPC, I have subnets. I can start launching instances, EC2 instances or virtual machines into those subnets, and then they can communicate with each other amongst the VPC. At some point, you're going to want to do something useful. You'll need to attach external connectivity into the VPC. So this is obviously one of the use cases. The use case of CSR comes into play. But Amazon has some of their own native tools to do this as well. So the first one that I show here is the Internet Gateway. So if you need internet access from the VPC, you can attach an internet gateway to your VPC, and that enables internet connectivity into that VPC. Now, there are 2 additional steps you need to take to actually enable that. One is you have to configure your VPC routing policy or route tables with a default route that points to that internet gateway. It shows up as a logical device in your VPC. So you have a default route that would point to the internet. And then the other is you need to allocate public IP addresses to the instances that want to use the internet. When you created that VPC and that CIDR block, that's your addresses, whatever those are. Amazon's not going to advertise those out to the internet for you. They're going to advertise their own address blocks. So when you want to talk to the internet, you allocate an address from one of Amazon's address blocks and assign it to your instance that needs a public address. So that is just kind of a nature of things in public cloud. So as the instance, it gets assigned the public IP address. Locally, it just knows its private IP address, and it gets one-to-one natted at the internet gateway somewhere upstream. And then the last thing I'll touch on in this slide are security, the security techniques for VPCs. When you create an instance, you have to assign a security group to it. So this is a per instance access control list, a layer 3, layer 4 ACL, that determines what traffic is allowed in and out of that instance. The other, and that's mandatory. Every instance has to have at least one security group. You can add multiples. And then the other is network ACLs. These are kind of like router ACLs. They govern traffic in and out of subnets. So if you need to restrict that scenario where I presented where all the subnets can just talk to each other in the VPC, if you need to restrict, say, traffic within that VPC for different subnets to talk to each other, you can do that through network ACLs, but you don't have to use those. So the other concepts that I want to introduce to baseline is the concept of a region and availability zone. So regions are distinct geographic regions where the cloud providers have services. So as an example, in the US, the AWS has regions on the commercial side in Northern Virginia, Ohio, Northern California, and Oregon. So these are distinct geographic zones. Generally, services don't span regions. So you have to recreate your services in most regions if you need multi-region redundancy or disaster recovery or whatever it might be. Within a region, there's a concept of availability zones. So you can kind of think of these as distinct data centers within that region. So for Northern Virginia, I think there's maybe 6 availability zones today, 5 or 6. And so these are distinct data centers. These are, separate buildings. They're on their own power, their own networking, and there's fault isolation between the different availability zones in that region. Now, a lot of services do span a region, so multiple availability zones, but others do not. So in the context of VPCs, I mentioned they'll span a whole region, but an individual subnet within a VPC is local to one availability zone. So you can't span layer 2 between the different availability zones, if it makes sense. And it's the same for EC2 instances in general. Because when you launch an EC2 instance, you put it into a subnet, you're effectively allocating that instance to one availability zone. So that's true of CSRs. When we look at some of the HA models, we put different CSRs in different availability zones for redundancy. So another native Amazon service for external connectivity are the Virtual Private Gateway, or VGW. So this is used in 2 contexts. One is for simple IPsec service. The other that I'll talk about later is in the context of Direct Connect. So this can be a gateway out of the VPC for either an IPsec service or a Direct Connect attachment to the VPC. So I'll describe the second use case later. So for the first one, it's a basic IPsec VPN. So it's governed behind an API. So you don't have like a CLI. You can't troubleshoot. Generally, you're troubleshooting it from the other side. But it has things like pre-shared key. It can be redundant. It runs BGP, but it doesn't do multi-pathing. So only one path is active at a time from the VGW. And then VGWs can't peer to themselves. And there's scaling issues as well. I think they're limited to 100 routes. So depending on how many routing topology looks like, there might be some limitations there. So it's good for simple use cases. I'll compare and contrast these to the CSR. They can be used instead of a CSR a lot of times in combination with CSRs as well. So for instance, 2 VGWs can't pair with each other. That's one limitation. So if you have certain scenarios where you're interconnecting them with IPsec, you have CSRs on one side, VPCs on the other. VPC peering is the last technique I'll cover. And that is a method of basically creating point-to-point links between two VPCs. So I have here VPC dev and VPC QA. We create, like, logically a point-to-point link between these two. This initially was only supported within a region. They just recently started adding inter-region VPC peering as well. The one limitation to be aware of that comes up a lot, and people use these, but it is point-to-point. There's no transitive routing on that association. So if QA here had an internet gateway, if it had other VPN tunnels, if it had other peerings, Dev would not be able to use those other connectivity options that VPC QA on the right has. It only allows traffic to communicate between those two environments. So it's A to B, A to B to C. So this compares a CSR to why you might use those technologies or why you might use those services. Or again, it's not always a either or. Like, I know in this scenario, I have customers that do the peering and then have CSRs on both sides of the peering to do an overlay network design. So they're used in combination with each other quite frequently. But if you're comparing them, scalability is one. So CSR scales to like 1,000 tunnels, hundreds of thousands of routes. Performance scale, we saw 4.5 gigs. So that's higher performance than the other techniques would be. Continuity of operations, so I can deploy similar capabilities and services to multiple environments, to multiple clouds. I have advanced routing features, so if I want to do something beyond point-to-point tunnels, I want to do things like multi-point tunnels, other advanced VPN designs, I have those available. I can do multi-pathing, so if I'm doing redundant tunnels, I can send traffic over both tunnels. If I'm building out hub and spoke topologies, I can do like a full mesh of connectivity for VPCs, using things like the MVPN, and then telemetry, NetFlow, AVC, IPSLA, the other telemetry that we can generate for monitoring. You do pay for bandwidth in these environments, so sometimes it's useful to get visibility into what's using bandwidth. These are the two deployment models to keep in mind. So these are more just, as I talk about features, just some context on which scenario. I try to say that in each slide, but there's a application VPC model that I call here, and this is like an access routing design. This is where I've deployed a CSR into the VPC with the applications. So I'm collecting traffic from the VPC and encapsulating it into a tunnel. So like access routing, think of I have a LAN interface on one side and the WAN interface on the other. The alternative is the transit VPC architecture. So this is more of an aggregation design. So the CSRs here aren't necessarily interfacing to applications locally in the VPC. This is where I've deployed like a network VPC within my environment, and it acts as an aggregation layer for all the application VPCs that I'm connecting in. And I'll cover that design a little bit later. But the types of features, the redundancy, how you would deploy these will depend on like which scenario you're talking about. So for the application VPC, and I'll describe the transit VPC in some detail in the design section. So just for the kind of application VPC, how does the CSR fit into a VPC? There are a couple of different ways to do this. One is one-armed mode. So if we have, Amazon has this concept of private subnets and public subnets. A public subnet generally is a subnet that has a IGW attached and internet connectivity, and a default route to the IGW. The private subnet does not have the default route to the IGW. So the kind of idea here is that the private subnet can communicate within the VPC, the public subnet can communicate outside the VPC, and if the private subnet needs to communicate outside the VPC, it's going to use some type of service in the public subnet to do that. A proxy, a router with a tunnel, some type of NAT device, etc. So this is a general model. When you're deploying CSRs, you can deploy them in one-armed mode, which would be just a single interface sitting in the public subnet. And then I use the VPC table to the VPC routing, internal routing, to get traffic from the instance to the CSR, and then the CSR would encapsulate it and send it out. And plenty of customers just use it. It's a simple design. Plenty of customers use this mode. This contrasts to a two-armed mode, so this topology up top, where I take the CSR and I have two interfaces. I place one in the subnet and then one in the public subnet. And so this routing policy points to the local interface, and then this has a interface in the public subnet that has a default route out to the internet. So this is a more intuitive, kind of natural network topology that we're used to seeing. So you can do either one, whichever ones you're comfortable with. I tend to recommend this one just because it makes more sense. I have local traffic on one interface, and then I have another interface. This is a variant of that I've also seen people use, where they want to put CSRs up in the public subnet, all the interfaces. They want multiple interfaces to separate the different functions: tunnels, internal traffic, maybe a management interface, and then they just put them in different VRFs. So they're all sitting in one subnet. The internal traffic might point to gig 2. Gig 1's used to terminate tunnels, and I might have a third for management. So that's also another fairly common option. And then if it's a production environment, you might want redundancy. And so we talked about availability zones. This is also a common model for production scenarios, where I have applications deployed across 2 availability zones, and I have 2 routers, one in each availability zone. I have a routing policy that points to one of the CSRs as the active gateway. And so a VPC routing policy can only have one gateway. For a given route, you can only have one gateway. So you point to one of the router, and then I'll talk about later, we have an HA feature that allows the CSRs to fail over. So if this router on the top fails, maybe this availability zone goes down, the route table can change to point to the other router in the other availability zone. So this is also fairly common. It depends on what you want. You can have a single CSR. It's not quite like a single point of failure because it's a virtual machine. If the hypervisor that it's on dies, you can recover the CSR. It's just, can you tolerate outages of minutes? It's usually like 5-6 minutes to boot a CSR. Maybe a little longer depending on the instance type. So it depends on what kind of outage you can tolerate. It's not necessarily you need to do this, but if you need, this failover time's on the order of a few seconds, usually. VPCs have some limitations. They're their own Amazon's homegrown networking technology, and they present Ethernet, but they're an overlay that's kind of recreating Ethernet, but not entirely. So there's no link local broadcast, there's no multicast, it hijacks the ARP process, and so it's just different than a normal Ethernet network would look like. And just keep this in mind for what services you're going to be running in that environment. So if you're using network technologies, local broadcast and multicast techniques, they're not going to work in this environment. So most times we have workarounds for the scenarios that people care about. We can use GRE tunnels to do dynamic routing. We, instead of using HSRP, we have an AWS HA mechanism. But this is just something to be aware of. So a lot of people ask about like layer 2 extensions into the public cloud environment. And generally, they don't work too well because they rely on ARP techniques, and it just doesn't really work due to these constraints. The other thing I mentioned was NAT is a fact of life in public cloud. So in the context of a CSR, it doesn't impose too many constraints. We have NAT transparency for VPN tunnels. GRE can work through VPN tunnels. But things like get VPN, if you're using get crypto, that doesn't work through NAT. So if you're going through a NAT gateway, just be aware that that might affect services. Obviously, when you're initiating tunnels from the other endpoint, you're initiating it to the public address, not to the local private VPC address. And then on tunnels, when you launch a CSR, you need to assign a security group to it like any other instance. Make sure you open up the ports that you need for terminating tunnels and for your application traffic. And you also have to disable the source destination check feature. By default, Amazon has this anti-spoofing feature that only allows traffic to and from an instance. So you have to disable that because a CSR is usually a transit point. It's not receiving or sending the traffic, it's in between the source and the destination. So you have to disable that knob on most of the interfaces. And then MTUs, as you're leaving the VPC, within a VPC, they do support jumbo frames, but when you're leaving VPCs, almost always you're limited to 1,500 bytes. So you have to account for that with your VPN tunnel overhead. So use things like IPMTU on the tunnel interface, IP TCP adjust access. Make sure you fix any MTU issues that might creep in. And then management. There's no console access in AWS. So when you deploy a CSR, the way you're logging into it is through SSH. There's no console. So if you start reconfiguring the interface, you have the potential to kick yourself out of the router if that's the interface you're logged into. So just be cognizant of that. And some customers use dedicated management interfaces for that purpose. So they have a separate interface that they can always get into. So that's another consideration. So that was the overview on CSR and AWS and how CSRs work in AWS. If you're new to that, that was probably a lot. I have some references at the end. There were some references sprinkled on some of the slides, but hopefully that made sense. And there is a learning curve that a lot of customers run into when they're getting started with VPCs and VNets and how to get all that working. So you have to do it a few times. It's not rocket science. You can pick it up, but you have to usually do it a few times to get comfortable with it. And a lot of traditional network engineers struggle with that at first. So, any questions on that? Sure. Right. So the question was on the NAT limitation, is it due to them not allowing you to advertise your addresses out to them? Right. That's the case. They advertise their own addresses. The VPCs that you create, they won't advertise those for you. So they won't advertise them at all. So that you require NAT. So if you have services that are running and using the internet, you can do one-to-end NAT, but if you want one-to-one NAT, like it's a public service you're hosting there, it's going to be reachable from an Amazon public address. They're only going to advertise their own addresses. So the question was a front door VRF. It was mentioned on one of the slides. That's a common technique for WAN designs. It's not specific to AWS, but as you get into, I have say a default route that points to the internet for terminating tunnels, but I might be getting a separate route for my enterprise network for over the tunnel. So VRFs and front door VRFs allow us to create separate routing tables for like tunnel traffic, for internal enterprise traffic. I mentioned that in there in one of the hidden slides later. What happens when you assign an interface to a VRF? Can anyone answer that? You lose your IP address. If you're SSH'd into that interface and you assign it to a VRF, you're going to get kicked out of it. So you have to be careful with that, and I note that. You can do it with either a dedicated management interface, or I have an EEM script as an example that'll configure the interface, put it in the VRF, and then reapply the IP address. So I have a sample of that in there as well. So, any other questions? Yes. You mentioned that Amazon will only advertise their own IPs to the public world. Uh-huh. So if you were to go to Amazon and grab space for just for yourself, they wouldn't let you advertise that out. No. So the question was, if you have your own public space that you've allocated to VPC, would Amazon advertise that out for you? No. If you want those applications to be reachable via that address space, then you have your own internet gateway. You don't use their local internet service. So you backhaul that traffic to a co-location site, to your enterprise, and use your traditional internet gateways that you advertise your prefixes with. A lot of customers do that. Probably more customers do that. Federal government has pretty tight controls of what, allowing connectivity to the internet. They have to be through approved gateways. So a lot of times they end up backhauling their internet traffic to go out one of their approved internet gateways. So you have to account, latency, it's not optimal from a bandwidth perspective. But, if you have to monitor packet level, say, data, you need to capture packets, there's not an easy way to do that in the public cloud. So It depends on what your requirements are. And there are ways to optimize that. A lot of customers are starting to adopt co-location architectures, where they build a network point of presence at a co-location site, which is where you'll go, when we talk about Direct Connect, if you want to get direct circuits into your cloud providers, you can build out a network point of presence at the co-location, and that gives you a low latency, high bandwidth path into your cloud. And then if you want to do internet service there, you could do it there and still do all your traditional kind of security stuff and whatever you need to do. And I know customers that do that as well. Yes? Sorry, can you repeat the question?
Have it met the federal government TIC compliant yet? You know what I'm talking about?
The TIC compliance? There are some, TIC, maybe we can talk about that offline. The federal government has a trusted internet connection requirement. They have to go through connections that are monitored by DHS and so forth. So there are some usages of that in Amazon, but that's a complex discussion. Maybe we could talk offline if you... Any other questions? The question was, between VPC peering, can you do VPC, or can you peer CSRs across that? No, you absolutely can. I have customers that do that. So some of them, the scenario is they want to take their public cloud environment and attach it into their enterprise environment without having to go through a bunch of security layers. They consider their public cloud environment kind of semi-trusted or maybe even fully trusted. So they try to limit the exposure of like internet gateways and public IP addresses and things in their public cloud environment. So in that scenario, they use peering, and then for the transit routing scenarios, they'll do tunnels over the top of those to allow transit routing in a VPC peering architecture. So, yes? Yeah, so we have, you can scale out CSRs in parallel, and that's a common technique in cloud. So you can do that today for the direct connect scenarios. You can scale that out, and that's the best way to do it today. So you can have 2 CSRs or 3 or 4, and you scale it out that way. We have an auto-scaling solution coming for transit VPC that will auto-scale based on bandwidth demands. So if you have 2 CSRs running, have a spike in traffic, it'll auto-launch additional CSRs and reconfigure the VPNs to load balance across those CSRs. So that comes in July, I believe, right? It comes out in July. So, okay, so I got to move on due to time. So I'll talk on general topologies here and then use cases around the CSR. So there are 2 primary use cases that we have. One is your on-prem enterprise extension into the public cloud. So I have an on-prem environment, and I'm building a public cloud environment, and I need to extend connectivity between my on-prem environment and my public cloud environment. There are 2 sub-use cases of this, and this just determines on how you might build connectivity. One is going to be where what I call the private app in a public cloud. So these are apps that are primarily, my users are internal. These are internal apps that I'm hosting in a public cloud environment. In this case, it makes sense to maybe take that public cloud environment and integrate it into my enterprise WAN. So I have my WAN today, I have my branch offices, campuses, and data centers. I can provide direct cloud access without having to hairpin through data centers, bottlenecks, potentially introduce additional latencies. So this is a topology where you might want to optimize that for your users connecting the cloud apps. As you pick up apps up out of the data center into the cloud, you don't want to start introducing high latency paths and traffic tromboning and so forth. So this is one scenario. The other is where maybe it is a public app and I'm using local internet connectivity in the public cloud, but I still need on-prem access to that environment, to on-prem, because maybe There are app services that are running on-prem. There's data that app needs to access. Maybe I'm doing monitoring management of that app from on-prem. I need just remote access for developers. I have automation tools, whatever that might be. They're running on-prem and I need to extend them into that environment. So this is more of a point-to-point scenario. And as I mentioned previously, I also know a lot of customers that do end up backhauling their internet traffic as well, and don't use the internet gateways. So that you might be backhauling it to a DMZ and then sending it out, your internet connection. The other use case is VPC interconnection. So I mentioned as you get into these environments, you might start off with a handful of VPCs and then you start to scale that. And inevitably, you're going to need to interconnect them because they have services they need to share. There may be shared services, so things like monitoring, directory services, DNS, logging, automation tooling, all that stuff might run in a common services environment that then supports all the applications. So you start to scale the VPCs and you get these interconnection requirements. This is a reference architecture we have called Transit VPC that of those use cases. It's good at capturing all of them. So it's a good architecture that a lot of customers deploy. And what we're doing is introducing hierarchy into our public cloud network. So we're creating an aggregation layer here for networking, and then we still have our application and spoke environments down here, maybe a shared services environment. As these spin up, they just attach to the local networking hub. The local networking hub does a couple of things. One is it can provide spoke-to-spoke access within the environment. So as a VPC comes online, it can get connectivity to all the other VPCs. And then it also serves as an anchor point to my on-prem environment. So I can extend my WAN and my connections into that aggregation layer. And I don't have to do that again. So that's done one time. That's a good question. So we do transit, so this is a reference architecture. There's a bunch of different ways to do it, and there's different instances of this. Usually you have CSRs in the hub. The spoke can be VGWs, or they can be other CSRs, depending on what your requirements are in your use cases. There's a particular version of this on the Amazon Marketplace that couples in CloudFormation, automation, and AWS Lambda. It uses VGWs in the spokes and CSRs in the hub. So you build out the hub one time with CloudFormation, and then as you bring spokes online, you create a VGW, you attach it to this VPC, and then you tag it. And when it gets tagged, that's a signal to the automation to automatically build tunnels to the CSR that are running in the hub. So that's one example. We have a DMVPN-based version of this as well. And then I know a lot of customers that have just built this themselves over time, and they use their own automation as well because this is mostly one-time effort, but you want to be able to automate the spokes down here to be able to spin up and spin those down. Yes, question. The question was, can you use Viptela virtual routers? So yeah, SD-WAN is a use case for this. There are vEdges in the marketplace if you're using Viptela and vEdge focus. We have plans to bring the vEdge, the SD-WAN features into iOS XE. That's not there yet. So today, if you're doing SD-WAN, you would use the vEdges. If you're doing traditional architectures, you would use the CSRs. So, and then at some point, we'll get an iOS XE-based SD-WAN appliance as well. Direct Connect, how many of you use Direct Connect today? I'd say that's pretty common for most enterprises is if you're a public cloud important, generally you're going to want some type of bandwidth guaranteed, good SLA path into that environment. So a lot of times customers are building out Direct Connect connections. These are just dedicated connections from your environment to the public cloud. So it's a circuit, usually 1 or 10 gig. You can get subrate circuits through partners, so you connect to a partner and then they provision subrate circuits services off of that. But if you connect directly to them, it's generally 1 or 10 gig. On there, you start carving up that one circuit to create logical services on top of that. And there are two primary services you can create. One is a private peering. which is what you use for connecting your VPCs to the Direct Connect circuit. So that's what's shown right here. On one side, you'd have a VGW that is different than the VGW. I mean, it's used in a different way than the VGW as an IPsec gateway. This is a VGW as a Direct Connect gateway. So you take that, you associate it with a logical circuit on the Direct Connect, and now that attaches that VPC directly to the Direct Connect circuit. So that's a private peering, a private virtual interface. The other is a public peering. So Amazon has a lot of services that run in public IPs and public URLs. And you're going to need to use those services. Your applications might need to use those services. So you can bring up a public peering. You treat that more as untrusted. That's just like, you know, peering to the internet. You're peering to Amazon over public addresses, public BGP ASNs, and so forth. These are some of the common topologies for Direct Connect. So one option would be I'm going to take and run a 1 gig, 10 gig circuit all the way from the Direct Connect meet me point at like at a co-location site to your on-prem. And I know customers that do that. They run it back to their data center, terminate it there. If you're using a service provider managed service, so CenturyLink, AT&T, Verizon, and you're getting IP VPN services, they do offer managed services around Direct Connect also. So they have connectivity into these environments. You can provision a logical circuit, and they'll attach it into your IP VPN services as well. So that's another topology. Another common one we talked about earlier is I can take and run a circuit into the colo from my on-prem and then build a network point of presence at the colo. So put a router in there, lease some rack space. And then I run a local patch from my router over to the cloud provider router. So the reason people do this is maybe it doesn't make sense for one circuit, but if you need to also attach to Azure, you need to attach to Google, SaaS providers you can build dedicated connection to. Maybe you want to put compute and storage here, so you start, or an internet gateway, as we discussed, or other security tools. So it gives you like a point of presence there at the colo that you can act as an extension of your cloud environment. So that is also pretty common. And then the last one I mentioned for completeness is you can also, if you put a router at the colo, like Equinix offers a service called Cloud Exchange, where you just plug into that fabric at the colo, and then they're plugged into all the cloud providers. So you go to their self-service portal and provision out a 50 meg circuit to Amazon and a 100 meg circuit to Azure and so forth. So that's another service that customers use. Bringing it back to the CSR, how does the CSR integrate into it, and what are the use cases? One thing is that none of this stuff is encrypted, and a lot of my customers have encryption requirements for compliance reasons. They have PII data, there's healthcare data, and they need to encrypt it from cloud to on-prem through the WAN. So that's almost a standard requirement for a lot of the customers I work with. So if I need to encrypt that, that's one use case. The other is the transit VPC we talked about. If I'm building an aggregation layer, then I can connect that transit VPC into the Direct Connect circuit and then integrate the CSRs with it from there. WAN extension into the public cloud environment is another use case. And then VRF extension, which I'll talk about in a little bit. If you're doing segmentation in your data centers and your WAN today, it's probably you're going to want to carry some of those segmentations into the public cloud. So we can do that with overlays and VPN tunnels, and that's another common use case for CSRs. The way we make this work is when we bring up the circuit, we create a private interface for the VPC the CSR is running in. We associate a VGW to it, running in Direct Connect mode. And then you have to do a BGP peering for advertising addresses, but all we need to advertise in this case are the tunnel endpoints to each other. We just need enough connectivity, because this is just transport, to bring up a tunnel. So if I'm doing the tunnel endpoints, the connected interface, or maybe it's a loopback, those are the addresses I need to advertise into the VGW. Once they can connect, then I bring up an overlay tunnel, and then I do most of my enterprise routing in the overlay. And if I need to encrypt that, I can encrypt that. So that's the way that integration works. You can also do it over a public interface as well. So if you did a public peering to AWS and you allocated public IPs to your CSR, you can peer to it that way if you want. Most customers do it this way.
Chris, so in that scenario, your customers don't require, they can have an open connection for the BGP peering, that's not a problem, only the data is flowing through the IPsec tunnel. The overlay. Because that's open, right?
There's two BGP peerings here. There's one for the underlay, just to learn tunnel endpoints, and then in the overlay, there's also, it can be BGP or it can be any routing protocol. This is authenticated. There's a, like, you know, by default, Amazon requires MD5 passwords for BGP peerings.
That's a private direct connect circuit.
The question is it a private direct connect circuit? Yes, direct connect circuits are always private. Any questions on that? Any other questions? Internet access, we've touched on this a little bit. You will have internet access requirements for your public cloud environment. This could be, you know, instances need to connect to repositories. It could be that you have public applications. Whatever your requirements are, you'll probably have some requirement to connect your public cloud environment to have access to the internet. A couple of different approaches for this. You could take and attach an internet gateway to each VPC and then allow local internet connection, but you have to maintain security, that distributed security boundary, and, you know, potentially deploy security appliances, or if you're comfortable with their native security techniques, whatever that are. It's just very distributed, and you just have to be okay with that security model. The other one we talked about is we just backhaul all the traffic to on-prem, and then it goes out our existing enterprise internet gateways. And then, you know, whatever I have here is the same stuff I'm using today for my data centers and anything else. As I introduce like a more hierarchy into the network with a transit VPC, we can centralize internet access in the transit VPC, or we can create like a dedicated security VPC and link that into the transit VPC that provides internet connectivity. So I can use native security features on the CSR. I can augment this with the security appliances, proxies, firewalls, other stuff. So this is another place where I can, if I want internet access directly in the cloud, but I don't want it distributed, I can potentially centralize it. And then we talked about the colo architecture. I can, if I have a colo tier in my network hierarchy, I could attach internet access at the colo as well. So, all right. Any questions on that? Yes.
I don't know if it's too complicated to talk about, but the part where you mentioned for internet access going through TNF for a service, is there any more you could talk about that?
We can, yeah, that is complicated, and I would actually point you to FANS, did a session yesterday. So FANS at TME for CSR. You covered the various transit VPC models, right? So I had, if you go to the transit VPC slide, I have his session ID on there. It was BRKARC-2023. He covers that in a bit more detail. So I'd point you to that. And then we're happy to talk to you about it offline as well. Okay, advanced features. These are, what other capabilities do I might need to use in the environment? Which ones are useful? Which other ones to be aware of? Cloud HA we talked about. So we described how HSRP won't work because of the limitations, but I do have HA requirements. So we have a native solution that we developed for Amazon. We have it for AWS. And at a high level, what happens here is I have application instances that are residing here. They have a VPC routing policy that points to one CSR. The two CSRs have a BFD tunnel, or a GRE tunnel running BFD between them. So they're monitoring each other for liveliness. One router is the active gateway for outbound traffic. And then if this router fails, the router on the bottom, let's say, detects that. It'll do an API call to Amazon API endpoint and modify the VPC route table to change the gateway from his virtual interface to his local virtual interface. So we're changing the VPC routing table to move the gateway between one CSR to the other. I have a lot of hidden slides with more details on this on how to do this. And there's also the config guide right here. We have plenty of customers use it. So what we're doing is recreating things like an HSRP experience for public cloud, if that makes sense. I mentioned VRF segmentation. This is also a pretty common requirement. So if you're using VRFs today, it could be VRF Lite, full-blown MPLS, and I need to carry that segmentation because I have different, I have a lot of customers that act like service providers. So they have different programs or different sub-agencies that they're supporting, and they need to keep them isolated. So they're building out a common AWS environment that a bunch of their tenants are going to come in and use, but they still need to keep them pretty isolated. So you go back to the transit VPC scenario, I could have, like a multi-VRF capable like aggregation layer, and then as VPCs come up, I could associate them to different VRFs and isolate them. So that's a pretty also common scenario. I can even do multi-VRF segmentation within a given VPC using things like subnets is kind of the VRF boundary. So I could take and associate subnets to particular VRFs as well if I want to do that. And that's not as common, but customers do that as well. NAT is another common requirement. So when you need to communicate out to the internet, you can do one-to-N NAT on the CSR to NAT instances to its IP address, so then they can get access to, say, a repository or something like that. We can do one-to-N NAT on it. We can you can assign secondary IP addresses to CSR, so you can create things like NAT pools. So generally, you can do a lot of advanced NAT things on the CSR in this environment if you have those use cases. So it'd be up for you to determine that. NAT is not stateful, though. So the way we cluster and do NAT HA requires link local multicast, which doesn't work today in AWS. So just be aware if you're doing like a redundancy mechanism and you fail over, it won't be stateful. Telemetry, another common use case. So how is my network performing? I'm doing this network extension. You're the network engineers. It's always the network's fault when there are performance issues. So it's useful for you to have some telemetry so you can triage network issues into these environments. So we have NetFlow, AVC, IPSLA. It all works the same way as our on-prem routers do. Same types of use cases. We can export to live action or whatever other tools, performance management tools that are sucking in those flow records today or doing IPSLA. Same use case for the security side. So you want to send it to a tool like StealthWatch or other security analytics tools to get visibility into, flow level visibility into anomalous behavior in your environment. That's another common feature that's used. And then there are other features, remote access VPN. So we support remote access VPN features. So if you need to AnyConnect into your environment, same kind of way you would consider that for on-prem. We have virtual ASA, and that would be the primary platform for that. But we do have remote access VPN features on the CSR as well. And then we have firewalling. Something new, we have encrypted traffic analytics. So if you're familiar with that technology, that is going to be supported is supported, or encrypted traffic analytics? It's supported today, okay. I haven't used it yet, but that's, if that is a good use case for you, that's supported on the CSR. All right, any questions? We're going to move on to Azure and then get into the automation demo. Yes? Yes, so the question was, do you have designs that show the firewalling between different environments? Yeah, that is covered more in fan section. Do you have that use case in your session? Using ASAs, yes. So I would point you to his session again. He has some more details on that. Is that inclusive of IPS? Yeah, so service chaining in these environments is challenging. So I would just state that up front when you get into these scenarios. A lot of caveats and limitations around it. And this is just the nature of running it. A lot of it's a statefulness. So you obviously need to control traffic in and out the same appliance for these type of things. And we talked about that you can't really, you have like one gateway and the clustering type features don't work. So We have advanced use cases of it, but it does take some effort to make that work. So. Yes. Yep. Their tools don't generally allow it natively, but you can do things with CSRs to allow that and so forth. So, yep. Okay. CSR in Azure. So this is going to be like 85–90% the same as AWS, and I'll try and spell out what the key differences are. Azure has a marketplace. If you want to use the CSR, you go to the Azure Marketplace, search on Cisco CSR, you'll find listings. One thing that's different is Azure has these solution templates that are an option. So when you create a CSR marketplace item that has the solution template, it'll actually create the VNet and the subnets and configure the routing tables and everything, so out of the box. We don't have that equivalent in AWS. We do have that in Azure. You can also launch a non-solution template version of the CSR that just places a CSR and say to an existing VNet. And VNets are the Azure equivalent of a VPC, virtual network. These are the performance numbers compared to AWS and then Azure. They're not quite matched up because we don't yet support SROV in Azure, but that's coming soon, right? November. So that's coming in November. So you should get a big jump in Azure performance numbers when we start supporting SROV in Azure, which we support in AWS today. Azure VNets or virtual networks, these are analogous to an AWS VPC. So all that description I did of AWS VPC applies to here. So we create a virtual network, allocate CIDR blocks, create subnets, there's routing tables. We rely on natting to get out. They have their own native VPN service. So a lot of things are the same. I have a slide that describes some differences because like VNet route tables and VPC route tables are a bit different, so when you start playing with those. The way the CSR runs in Azure VNets is effectively the same way it runs in AWS. As a gateway, you configure it, you can do it one-arm mode, two-arm mode, you configure VNet route tables to redirect traffic to it. It has tunnels going out. So again, it fits in generally the same way as you would in a AWS VPC. These are some of the differences. I mentioned the solution templates. That's kind of a Cisco-specific difference. I don't know if that's Cisco-specific, but for the CSR 1K it is. I mentioned VNet route tables and VPC route tables. By default, when you create subnets, they belong to like a default route table that gets populated with these things called system routes. And you'll see all these RFC 1918 routes. There's a default route that points out to the internet, so you don't have to attach things like internet gateways. That's another kind of thing that you just have outbound one-to-end NAT access by default when you boot up a VNet. So you just have internet access by default. But if you want to create custom routing policies, you have to create a custom route table in Azure, and then you add what are called user-defined routes. These route tables can be shared actually between VNets. So again, another difference between VPCs, where VNet's always within a VPC, or VPC route table is always within a single VPC. In Azure, these custom VNet route tables can be shared between VNets. So you have this default route table and then the custom route table, and this just gets some experience playing with that. So just creating awareness. The other key thing is VNet peering in Azure allows transit routing. So that allows us to do some other things in Azure that we can't do in AWS. And I have a slide on that. Availability sets versus availability zones. So Azure did not initially have availability zone concept. They had what were called availability sets, which were basically like anti-infinity rules. So if I say that these two instances are an availability set, it means I want them to run in different racks, is kind of the granularity that Azure had. So don't put them on the same hypervisor, the same switches. They didn't have really the full availability zone kind of separation concept. Now I think they have that coming, or it's in preview in some Azure regions. So maybe that'll normalize over time. But today, a lot of times you deploy HA in Azure using availability sets instead of availability zones. And then another caveat is GRE actually is not supported in Azure. So I do have customers that just need overlay routing without the crypto, and they run plain text GRE in Azure, but that doesn't work in AWS, but that doesn't work in Azure. They actually block GRE traffic, only allow like TCP and UDP and IPsec. Everything else gets blocked. This is a CSR hub and spoke architecture using VNet peering and the transit routing features of VNet peering. So I think for sake of time, I can't spend too much time on this, but the idea is I have my spokes, I bring up VNet peering, and then I create these custom, user-defined routes and route tables that point to gateways that are in a foreign VNet, that are in this hub VNet here where CSRs sit. They have their own native gateway, but you can use CSRs for that as well. And so basically now these are doing inter VNet routing. Same kind of use case. I can use this as an anchor point to express route back to on-prem, et cetera. So this is just the routers are acting as centralized gateways for inter VNet forwarding using the native VNet feature. You still always have the option to also deploy the full transit VPC with overlay tunnels in Azure as well. And these can be the Azure Virtual Gateway, or they could be CSRs in the spokes. So same kind of architecture as what you would deploy in AWS. And then Azure with Express Route, what I described with bring up the Express Route, configure a virtual circuit into your CSR VPC, bring up a BGP peering. This is their Express Route Virtual Gateway, equivalent to the Azure, or the AWS Direct Connect Virtual Gateway. They have a requirement that you have to create this subnet to place it in. They actually are running instances underneath to get placed into the subnet. So you have to create this subnet, and that's what your virtual gateway runs in. But once I have this up, if I'm running CSRs, I bring my tunnels up, and then I do overlay routing over the top of that. So basically same as the AWS Direct Connect. So we also have the HA feature works in Azure as well. So the HA solution I described for AWS, there's an equivalent to Azure as well. All right, automation. So my statement up front was I think automation is really key. I encourage a lot of customers when they're going in the cloud to think about an automation strategy especially for their cloud network environment, because we don't want to go back to traditional kind of change control methods and slowness. I mean, cloud's about speed and agility, so we want to be able to automate the network like all the other infrastructure. AWS, so one easy way, what a lot of people get started with is using CloudFormation to do this. So if you're familiar with CloudFormation, it's similar to Azure Resource Manager templates, OpenStack Heat, and then we'll talk about Ansible and Terraform. These tools that can do infrastructure creation. So I spell out in a file with JSON in it or YAML, build this infrastructure, build this VPC, create these VNets, allocate these public IP addresses, configure these route tables, create these virtual interfaces, launch a CSR. You can do all that. It's basically an infrastructure creation automation tool. So I define that in a template, I run it through their CloudFormation engine, and out spits a CloudFormation stack. And this is a stack of infrastructure. I can then delete this, and generally it'll wipe most of it out. Not always, but usually. And this is CloudFormation, and this is a good starting point I mentioned that transit VPC, I need to spin up application VPCs. This is a good way to do that. Now, this doesn't configure the CSR, so we still need automation for actually doing router configs. And so we have things like Ansible, which we'll talk about. We also have programmable interfaces and whatever network automation technologies you're looking at that support iOS and iOS XE devices would be relevant for automating CSR configurations in public cloud as well. And the other thing that is pretty cool that we've just recently started supporting is guest shell on the CSR. So we have, guest shell is basically spinning up a bash environment on the router. So it runs isolated from the host OS, so it's not like getting a bash shell on the host OS. It's running in an isolated container. It's running in a container. So iOS XE under the covers is Linux. So we're leveraging, you know, the native Linux like hypervisor technologies and whatnot to spin up isolated environments. So guest shell is basically a bash shell that runs in an isolated environment. And then in there, I can run on box Python. So if you're spending any time with Python as a common network automation language, we have an embedded Python interpreter. And then we can start to do interesting things for cloud. So I can start to interact with cloud APIs in my environment. So one thing you can do is say, get instance metadata. And instance metadata is what the hypervisor knows about the instance it's running. So things like, what subnet am I running in? What is my instance ID? What security groups are associated with that? You think you're inside an instance, you have really no clue what that is. Well, you can query this thing called instance metadata to find out about your environment. You can copy config, show command data, tech support data to object storage. So that's a pretty nice feature, object storage. You get a URL for it. You can so do a dump a tech support or back up my config to Amazon S3. So that's another use case. And you can also take and export custom metrics to CloudWatch. So CloudWatch is Amazon's native cloud kind of metric monitoring tool. So you can do alarming and whatnot. Like we've done demos where we take like drop counters, export those to CloudWatch, have that send out alerts, have it send a message into the Spark or WebEx team rooms, and so forth. So I can do a lot of cool things with this. Here's a GitHub repo that has a bunch of built-in scripts that one of the CSR engineers developed around actually these use cases here, if you're interested in that kind of stuff. All right. Go ahead.
Time for the demo. If you've wondering what value the other guys adding to this presentation, it's the. All right, so what do we have? We will have a 3-node demo. The idea is to show you some of this stuff in action, to enterprise, make some of this enterprise ready. We start with 2 nodes. This node right here is in San Jose. It's an OpenStack cluster. It's a physical site. This site right here is Azure, also with a CSR configured. It's already provisioned, and I'll show you that. What we'll be doing in the demo is rapidly configuring site 2. This will be in AWS. We'll probably put it in AWS West. And I'm going to show you Ansible Tower to do that. So first I'm going to show you the current state of that network I'll just show you the show IP int brief. And what this will do is this will go run a show command on each of the routers, and it'll come and report that information to us. And by doing so, we can see the routers that are currently in this network. This pause, Ansible Tower, and I'll explain this a little bit, but it schedules out the running of these automation tasks so that you don't overlap or you serialize these automation tasks to a particular router. But what we have here is our San Jose, our physical site with OpenStack. We've got our Azure Site 1. It's Azure East Coast, East US. And we've got on our Site 1, you can see that we've got this is in 2-armed mode. All of them are that I'm going to deploy here. But we've got 2 interfaces. We've got a DMVPN tunnel, and we've got our San Jose site. So what I'm going to do is I am going to go and start the deployment of our new cloud node. So it's part of my prod network. I'm going to call it Site 2. I'm going to choose, so I've got different models. I've got a 1-arm, 2-arm. I've got one with an F5. I've got the hub, the MVPN, the transit hub that Chris was talking about. And I'm going to deploy it in US West 1 and assign a CIDR to it. We're going to see this start up. First thing it's going to do is it's going to and I can get into details later how this works, but it's a model-driven approach. We define a model once of the kind of models that Chris was talking about, and we can deploy it into any of these 3 clouds that I talked about. So it's taken this model, and it's going to convert that model. In the case of WS, it's actually going to convert it dynamically to a CloudFormation template, and it's going to push that CloudFormation template up. So what we see, if we go to CloudFormation, we'll see that stack starting here right now. This is in US West 1. So we're going to let that run a little bit while I talk about the rest of what we're doing. So that task or that workflow is provisioning this Site 2 node. It's a DMVPN overlay, so this could be cloud sites, this could be physical sites, so it's either provisioning the node and spinning up the CSR router, waiting for it for you to configure the rest, or it could be a physical site. So if you've got an ISR, you can pre-provision that, you can send it out to a point of sale, site, and then you can then bring it in, provision that, and bring it in as part of the network. Either way, it's the same. They're all iOS XE. They're all interconnected via DMVPN. So after this comes up, we're then going to run through a workflow and I'm going to combine it in one workflow for the sake of time, but what it'll do is it'll go configure this router, basically do all the things that make it ours. It goes and configures the domain, configures the host name, the IP addresses, hardens it, backs it up. And then it's going to go and it's going to run it through a process to bring it into the DMVPN overlay. And I'll show you that as it goes. Just a little bit about Ansible. Who's heard of Ansible? Who's used Ansible? Okay. Ansible is an open source infrastructure as code tool. The idea is that you define the architecture, the intent, everything you want from your infrastructure as code, and you manage that as code, just kind of like you would an application development lifecycle. So the lifecycle of your code is the lifecycle of your infrastructure. Its main goal in life is to seek the end state as defined in that code, or the playbook, to use Ansible parlance. But it doesn't just spray out configuration every time you run the playbook. What it does is it sees what the desired end state is as enumerated in that code, that checks the actual end state of the infrastructure, and then it will only do those things that it has to do to bring the infrastructure in line with what that code specifies, right? So in the paradigm of Ansible, configuration and compliance/remediation are done through the same mechanism. The first time you run a playbook, it will configure that device. The second time you run that playbook, it will make sure it's continued to be in that configured state. And if not, you can tell it to just report or to directly remediate. The design principles are to be easy. It's really an abstraction layer above Python. You can leverage Python through modules, through plugins and Ansible, but the idea is that most network engineers are not Python programmers. Maybe they shouldn't be Python programmers, but maybe they should have the ability to leverage Python in an easy way. And this is what Ansible tries to do. It's powerful in that it has lots of modules to do lots of different things, from routers to cloud to PDUs to light bulbs. And agentless in that you don't have to have an agent running on that device. What we do is in the case of servers, we process this playbook and we'll shove Python to the server, and the server will process that Python. So on the network device, we can't reliably count on a Python interpreter to be there, so we actually process that Python on the control node or the Ansible tower node that I'm showing. And then we will talk to that device either via CLI over SSH, via netconf-yang, or via API. So we can talk to most devices that you've bought in the past 15 years and automate an infrastructure. And it's for a full life cycle. So we can do provisioning, we can do day one, we can do day two, we can kind of keep your infrastructure up to date and automate it via an API. So we go back to our demo. What we've done, so we've built the node. This is the first step of the workflow. And then we've updated the inventory. This is the idea of source of truth. Generally, the source of truth are all the key value pairs in your network that describe the interfaces and the name and whatever your network. You're going to have this for automation. Automation needs the source of truth information to be able to reference it, to push it out. This is a cloud, so it's dynamic. So what we're doing is after we've created this node, we're querying the cloud, and we are updating our inventory with all of the interfaces and such of that cloud. And then we sit here and we wait for the CSR to finish booting, which it just did. So if we look at the current state of our network, we go back to our show command, and we run a show IP int brief. We should now see that we've got that third CSR has been spun up, right? And as you can see, one of the ideas, Chris and I have done this demo, I think, for the last 4 years with Ansible. Previously, we did Ansible Engine, which is a text-based command line version of this. It's very good at sort of automating one nerdy engineer, right? But when you want to make it when you want to make network automation approachable by the rest of the enterprise or usable by the rest of the enterprise, a GUI like this is really important. So as you see, as I've been running these playbooks, it's been asking me what we call surveys. So we run a playbook, we give it some information, it goes on its merry way. Pretty much most operators could run this. Most people in most network groups, this would allow them to leverage that automation. The GUI is Ansible Tower, correct, yep. All right, so what we see is we've got 3 sites that come up. We still got our San Jose site, we've got site 1, and site 2 has come up. We see that our interface is not configured. We don't see a DMVPN tunnel. So what we'll do next is we will go and we will bring it into the DMVPN overlay. And this is another workflow. This workflow is a little bit different in that what we're going to do first is we're going to checkpoint all of the routers to see, okay, what's the current state before we go change anything new. And then after that, we're going to go configure all the system things. Now, normally I would probably pull out the configuring the system into different steps, but we're going to put one big step here for brevity. And what you'll see here is when we start configuring the network, it's as I stated before, what it does is it goes and figures out what that current state is of the network, and then only does those things that are different. And if you notice, the green things, the green tasks, or the tasks that report back as green as OK, when it comes up, means that nothing's changed. So when it goes and configures the host name that scrolled by, the host name didn't change on the site 1 or the hub, right, the San Jose site, but it did change on the new site. And if I ran this again, it would come up with all green, right? That's the idea of it seeking a desired end state. Then what it's doing right now is it's going and pushing out the DMVPN overlay. And if you notice, I didn't go configure site 2. What I did was, okay, Ansible, I told you the way I want my wide area network to look. Go make sure that every device in there is at that desired end state. Site 1 and the San Jose main site, the data center, were in that end state, so it did nothing. Site 2 was not, so it went and configured all the things with the system. Here, it's configuring DMVPN. And then at the end of that, I'm going to go do a check to make sure that everything is up. And what that check will do is, when it pops up, it'll configure DMVPN tunnel interface to DMVPN tunnel layers. On every single router, it will ping every single other router's DMVPN tunnel interface. And then it will ping the loopback interface, because we advertise our loopback interfaces into EIGRP, so if we can ping the loopback interface, we know that the EIGRP routing fabric is up and righteous. And if you'll notice, one thing that I did here in this particular workflow, at every single step, I said, okay, on success, go to that next step. On failure, go ahead and roll back. So at any step, if something went wrong, I could roll back to that very first step. And then as it completes all the steps, I say, okay, we're good here. I'm just going to go back it up and sort of checkpoint the state for this network. So when I go back and I look at my interfaces now, what I'll see here is Site 2 now has a configured inside interface. It's Gigabit Ethernet 2. It has a tunnel, and it's ready to go. All right, so this is our Site 2, and you see all of our interfaces are configured. We now see our tunnel interface. We see our loopback interface, because these playbooks also configure a loopback interface. And then the last thing we'll run is we'll do a show route. And that will go and show us all the routes. So we can just validate that we're seeing all the routes for all the different sites in the places where we expect them to be seen. So if we look at the hub, we can see our routes. So now we see the route for site 1, we see the route for site 2 at the hub, and we see the loopback interface. The very last thing I'll do, or the second to last thing I'll do is, I'm just going to bring it all down, right? So we're done. We've spun up this node. We've accomplished whatever temporal, ephemeral task that we wanted to accomplish, and then we can bring it down. And then as I mentioned, it makes it more consumable, right? The idea is that you don't have to, an engineer doesn't have to go run a playbook to go do something. An operator can do it. Or even better, Ansible Tower, right, which is this GUI that I've been showing you that runs these playbooks, it also has a REST API. So every single playbook, every single workflow I have can be called as an API. So the majority of the customers that I have are integrating their automation with something like ServiceNow, where you request something, an end user requests something, it goes through the approval process of ServiceNow, and then ServiceNow goes and calls Ansible Tower to run a playbook or a workflow to accomplish that task. And this is the theme of don't just focus on automating a human, focus on automating a business objective. You can schedule those jobs to validate that what we call deviation from end state. So I'm gonna hand it back over to Chris, and if anybody has any questions, I'll still be here afterwards.
Do you have?
No, sir, you have it.
Oh, right here it is. Okay, so we're just gonna wrap up. So we covered the 2 primary use cases, the enterprise network extension and also the VPC interconnection. We talked about transit VPC. We talked about the VPN use case designs, all the extra capabilities, the advanced routing capabilities, firewalling that, the telemetry capabilities we get with the CSR, and really the multi-cloud use case of being able to do. So if you notice in that environment, we had on-prem, or that demo, we had on-prem, Azure, and AWS. So we can do similar or the same operations and same capabilities in all my environments. We talked about the HA, and then we talked about automation as well. I mentioned this at the beginning. If you want to play with the CSRs at all, you can launch them from the marketplace and just pay for the instance costs. So when they boot up unlicensed or in BYL mode, unlicensed, you can use all the features, just you're capped at a megabit per second, and when you want to test performance, you just get a 60-day eval license. Here's some additional resources. So Fan has done a bunch of YouTube videos on a lot of the stuff actually I've covered in here that shows you kind of step-by-step going through configurations and how to bring this stuff up. There's also config guides for AWS Azure. We starting to launch more multi-cloud design guides, so I have a link to those as well. And then if you're new to AWS and AWS VPCs, I included a link to their reInvent presentations. reInvent is their user conference, so they have they post recorded versions of those presentations on YouTube. And then there are a couple of mailers here. They hit the product team if you have questions. These are a couple of related sessions. I mentioned Fans was yesterday. There's another one called Multi-Cloud Networking tomorrow at 10:30. And then there's this one as well that covers the transit design. This is a customer use case that a customer is co-presenting with. And then we're going to plug our own session we're also presenting on Thursday. We're doing a continuous integration, continuous development demo for networks using Ansible in the DevNet zone on Thursday morning, rather. So, and that's it. So if you guys can please do your sessions, I appreciate and thank you for your time and questions and attention. Thanks very much.